Dr. Atchison here, and we're talking about Chapter 5, Perceiving Color. This is our first lecture for Chapter 5, talking about light and the dimensions of color. So first of all, how does the visual system do this? How do we perceive color? What's interesting is that objects themselves don't actually have color. They're not the things that are colorful. What is happening is that we're seeing color. We're perceiving this. And it's the refraction of the light reflecting off whatever that object is. What's neat, though, is that different organisms, so us versus dogs versus cats versus any other kind of organism, don't necessarily see the same objects as being the same color. Even different people don't see the same objects as the same color. The most famous example of this, not maybe the most famous, but one of the most famous recently, is the dress. There was a group of people that saw it as gold and white, and there was a group of people that saw it as black and blue. And there were some other combinations too, but those were the two major groups, and social media exploded over which color it was. And so again, different organisms and different people don't necessarily see the same objects as being the same color. That perception is different for different organisms. So, how is this happening? Color is a perceptual experience that's evoked by by how the wavelengths, these different wavelengths of light, reach our eyes, okay? And how we talk about this is in terms of a spectral power distribution of light, which sounds really big and fancy, but it's really just a graph that can tell us about the intensity or the power of light at each wavelength in the spectrum. So remember when we talked about light way back at the beginning, when we talked about it, in Chapter 2, we talked about that kind of visible light, and within that was that spectrum of light that we're used to seeing in terms of that rainbow. So this SPD is just basically a graph that allows us to see the intensity of these things. And again, it gives us information about what light is being reflected. And again, whatever that light's being reflected is what you're going to perceive that as in terms of color. So if you have a red binder, what's happening is the red light is being reflected back at you, and that's what you're perceiving, is the reflection of that red light coming off. So here is an example of an SPD. Again, this is usually depicted in a graph, and it's really an important tool that we use in determining light. So we'll have several different, there's two different Launchpad studies or demonstrations that will use these, and you can kind of see how there's different wavelengths and how different parts of the visual system process these different wavelengths. There's also different kinds of light. There's heterochromatic and monochromatic. And this is the idea that the intensity of each light depends on the source. So if we're getting light from a sunlight versus light from a light bulb that's incandescent versus a CFL versus an LED, these have different kinds of light. And this is that wide idea of heterochromatic light, that there's a wide range of different wavelengths. And this is light that contains more than one wavelength. So again, when we're seeing, light from the sun, that's got more than just one wavelength in it. It's heterochromatic. Remember, hetero means different, and so heterochromatic just means different colored light. But together is going to be one. The most pure form of this is achromatic light, which contains wavelengths from the entire visible spectrum. So that's what we're getting. That's what we get with sunlight on a clear day. That we're having, and we can see that refracted with those prisms. Okay, this really has no dominant wavelength, so it's not going to have one wavelength that's higher than others. Its SPD is going to basically be a straight line because it's every different visible part of the visual spectrum is going to be displayed equally. It contains the entire spectrum, but again, there's not any dominant lights in those spectrum. This is opposed to monochromatic light, which is just a single wavelength. So if you have red light it is just red light. There's not other lights in there. It's light that, again, is only consisting at one wavelength. So again, what we're seeing as light is that reflectance of that particular part of the spectrum back at us. What we're seeing as color is that reflectance back. So a spectral reflectance is a part, the proportion of light that reflects a surface at that particular wavelength. So again, it sounds big and scary, but again, it's talking about what part of the spectrum is being reflected back. And so again, it's the amount of light that's being reflected back to our eyes from the object. Different objects have different reflectances. Black paper reflects less than 10% of the light that hits it. So one of the reasons that we're perceiving it as black is that it's, again, reflecting very little light back. You know this when you wear a black shirt on a hot day, on a sunny day, is that it's going to absorb that light. There's very little of that light that's being reflected back because, again, your shirt's absorbing it and you feel that, you get hot. Whereas white paper or your white t-shirt will reflect more than 80% of the light back. And again, that's part of the thing that's allowing us to see these things as different colors, is the amount of light that's being reflected back. And again, you can feel this on a sunny day, the difference between a black t-shirt and a white t-shirt, and how much light is being reflected back versus how much light is being absorbed by that t-shirt and then by happenstance you. Okay, so let's talk about these dimensions of colors. Now, this is stuff that you're probably going to be a little bit more familiar with. And this is hue, saturation, and brightness. These are those physical components of light and surfaces that, again, allow us to evoke this experience of color. And remember, these are subjective experiences of color. Remember the dress. Not everybody agreed on the dress. There's subjective experiences of color. So again, we have hue that refers to the color, okay? So it's going to be most closely associated with that actual wavelength of light. But when we think of whatever, this is red versus blue versus green, we're talking about the hue. We're talking about the color. The saturation is telling us the vividness or the purity or the richness of a hue. So when we look, here in a second, I'll show you an example of that. And brightness is telling us how much light is in that. So is it a very dark? Is it a very bright? Brightness or intensity is going to be that third dimension. So that with those three dimensions, there is a way to represent those in what we call a color solid. And it represents all three of these dimensions. Hue is around the circumference. You can see that here on the kind of the base of the cone. It goes around the outside. And you can see that we have yellow and then red, orange and then red and then pink and then purples and blues and greens and then back to yellows. And it's around that circumference are those different hues. Saturation varies along any radius. So from the outside to the inside, it's going to change, okay? And brightness is going to be that third dimension. It's going to take that circle and make it into a cone, and it's going to vary vertically, okay? So again, that's going to be how much, kind of the intensity of those colors, the brightness of those colors. What you're most probably familiar with in terms of hue versus saturation is this 2D depiction, this color circle. We use these I know I use them frequently when I'm making slides, where again we have hue around the outside and we have saturation along the inside. So when you play with a color circle on any number of programs, again, you can pick the color going around the the circumference, and then you can pick how the saturation of that color on the radius. We're going to have kind of the darker, like more muted tones in the center. We're going to have the brighter tones towards the outside. So I'm going to kind of go through these rather quickly because there's a good video activity that I've assigned for you to watch and participate in, and then answer a few questions on for a class assignment this week. There's different ways to mix colors, okay? What we are going to talk about a lot is going to be this additive color mixture. And this is the one that you're probably not as familiar with. When you think of color mixing, you probably think back to elementary school and when we learned how to mix paints. That's actually subtractive color mixture. So additive color mixture is talking about mixing lights, different colored light, and we have the primaries for additive colors are red, green, and blue. If that seems weird to you, your monitor is probably an RGB monitor, red, green, and blue. It's reflecting light back at you. Your smartphone, RGB. It's about the mixtures of light. Subtractive color mixture, those primaries are red, yellow, and blue. Those are the ones that we're most familiar with in terms of our elementary school art classes because we're mixing substances. And the difference here is that additive mixtures is reflecting the light. Subtractive color mixture is mixing substances. And because the reason there's a difference is because the substances are going to reflect back the light. So there's a different layer there. Again, there's a really good video activity that walks you through these. So again, additive is additive because the perceived color is a mixture of adding the wavelengths together. And again, you'll be able to see that in the activity. Whereas subtractive color mixtures is again about substances. And it's the reflectance of that surface back at you. So you can see here blue paint is reflecting back mostly blue light, a little bit of green light, but mostly blue light and absorbing the yellow, the orange, and the reds. Whereas yellow paint is primarily reflecting back yellow lights and some of the oranges and the reds. Again, we see these differences. And it's called subtractive because each substance in the mixture subtracts certain wavelengths, takes them out of the issue. So we'll take in a blue paint, we're taking out the yellow, the red. They're subtractive there. Okay, so complementary colors. Again, this is some back to our elementary school art classes. These are those pairs of color that when combined in equal proportion are perceived as a shade of gray. These also have hues that are exact opposites of each other on that circumference of the color circle. And again, primary colors, we've talked about them a little bit for the different additive and subtractive color mixing methods. Again, they vary. There's not a unique set of primary colors, which is, again, not what we learned in our elementary school art classes. But again, we're talking about light. If you have any background in theater and light mixing, then this is not new to you. You have experienced this previously when you're using the different kinds of light to create a different color. You use different primaries than you would use in mixing paint. So again, do that video exercise on those, and it's very helpful and answer those questions. Thanks. Bye.